There we go. Okay. Today's lab is routing. This week's whole module is routing. And if you don't really like Linux and Unix, here's one for you. I say that because this routing lab will really help us review how routers work and how to set up routing on hosts, as well as how to set up routers. So it's got broad value in that we practice our routing skills, and we happen to do it in Linux. Tomorrow's lecture, I think, is one of the best lectures in the set. So if you can make it, I encourage you to do so. Today, though, we have a cookbook lab where we set up a router. Let's have a look at what we're going to build. The bottom part of the diagram, sorry for that loudness, the bottom part of the diagram looks pretty familiar. Right? W01, S01, Blue Network, NAT network out to the internet for W01. We get all of this bottom part just by importing the appliance. But we're going to create a new server, S02, and put S02 on a new network segment, the yellow network segment. So we're going to clone, we're going to make a new segment. Can S02 talk to W01 directly?
No.
They're not connected. In this picture, what's the only way S02 can get a packet to W01?
Route through S01?
It's got to go through S01. Well, that means we've got to make S01 a router if we want S02 to be able to send packets to W01. Quick refresh on routing and how it works. If S02 has packets for anybody on yellow, it can put the packet directly on yellow and send it to its destination. But in order for S02 to send a packet to the blue network, it has to send a packet to S01. S01 has to forward that packet. W01 has to then send its response, but it can't send its response directly. W01 has to go through S01 as well. It's a little hint that we're going to have to make sure we set up the routing correctly on W01 as well. Let's get to work. Set up the lab. Import the appliance. Got it. Clone S01 to create S02 and reinitialize the MAC address of all the network cards. And attach S02's network adapter to the yellow internal network. We're going to clone. Include only, no, it's not what I want. Generate new MAC addresses for all adapters. I'm going to do a linked clone because it's quicker. Now, we don't want this to be S01 clone. We want it to be S02. And we want him on the yellow, not the blue. Oh, wait, what? There's no yellow. Have no fear. I can just type in yellow. The first time I do this, it will create an internal network called yellow. You'll see later we'll be able to get yellow out of the drop-down list. I think S02's VirtualBox stuff is good. Add a second network interface card to S01. Internal, yeah, okay. So we need, these guys need to be connected on the yellow. So we're gonna go to S01. Network. Second adapter. Enable. Internal. There's yellow. Configure the network interface card we just added to S01. Well, IP, I guess I need to boot S01, don't I? There we go. Shouldn't take long. We're going to run IP adder, and we should see S3 set up with .20. It's our original interface. The new interface, S8, should not have an IP address configured. Let's verify that. Sure enough, IP address on S3, S8 is awaiting our commands.
Looks good.
Let's have a look at what Network Manager knows about our cards and connections. NMCLI connection show. S3 is green, all good. The device is S3 and the connection name is S3. On a server where we're only likely to have one connection per card, I like to make my connection name the same as the card's name. You don't have to. You could call them yellow network and blue network. You can name the connections anything you like. They should be in some way descriptive. I don't want it to be called wired connection 1. I want it to be called ENP0S8. I can use network command line. We're going to peek at the lab. I tell it what connection name I want, and then I set the attribute to this value. It's connection.id. Connection.id. That looks kind of PowerShell-y, doesn't it? And was it an equals or just a, nope, just a blank? ENP0S8. And check our work. Oh, see, name changed. That makes me happy. They're nice and consistent now. we're going to set the IP address and make sure that the mode is set to manual and not DHCP. See if I can remember that. I think I can't. So I'm going to put it someplace I can see it. Yeah, there we go. Oops. Oops. Now, can you take a look and do a quick QA on that? Make sure I did that right? I think I did. We can always fix it later, and quite frankly, that'll be more interesting. It'll be more stressful for me, but it'll be more interesting. Oops, sorry. Thought I'd get fancy and recall the line and edit it, and I will not be denied. Now we need to apply our changes. And we do that by telling Network Manager. Oops. Let's have a look. One 1.20, 2.20. That looks pretty good to me. I'm satisfied with my work so far. Add the new interface to ETC hosts. It's kind of a little tricky because now I've got two IP addresses for the same host. What we're going to do in this lab is call them S01 blue for the IP address on the blue network, S01 yellow for the address on the yellow network. And by having S01 as a name all by itself, that's going to allow 10.1.1.20 to be the default. If I ask for just S01 from this host file, I'm going to get the 10.1 network. Now, because I don't have my W01 copy paste stuff working, I'm going to have to do this the old-fashioned way. Type in at the console, no cut and paste. So S01 is also S01 blue. And on the 2 network, it's S01 yellow. We got W01 in there. And S02. 10.2.1.30. Yes. Okay, let's see if we can ping ourselves. That looks good. Now we'll ping the .2 network interface. That looks good. How about by name? I think we have a winner for part E. Oh, can we still reach W01? So now we need to give S02 a new identity. Might need to go back to the System Identity Lab for reference. We're going to set the host name, set the IP address, and update the host file. Okay. Where's S02? Waiting patiently. Some of you have asked about this error message. It comes from a VMware supplied kernel driver that VirtualBox uses, but VirtualBox doesn't use it, I guess, exactly the way that VMware wants it used, and so it spits an error message. It's an error message that is, it's not quite meaningless, but it doesn't indicate that anything's really broken. My guess is VMware and VirtualBox Oracle aren't the best of buds, so it might not get fixed for a while. First things first, the host name. This one I remember. There's a file called etc host name. And the host name should be now 02. We also have to change the IP address. Fortunately, we don't have to look all the way back to our System Identity Lab to see how to set the IP address. We have an example of it not very far away. We modify the IP address parameter. I think I can do that. Oh, you know what else might be? I might even still be in the history. Look at that. Command number 49 from way back when I initially configured the virtual machine. It's still in the history. So we can see that, well, we set the IP address with command number 49 there. I think I might even be able to recall that command. Escape, I'm going to search for oh, see what you can do without cut and paste and a mouse on this old operating system. The reason you can do all this cool stuff without cut and paste and a mouse is for decades they didn't have cut and paste and a mouse. So they came up with all these little tricks and put them in that would work in environments where you don't have a clipboard. We are now on the yellow network, and we should be 30. And we follow that by that looks pretty good. The host name hasn't changed yet, but I think we'll need to reboot for that. Let's see if there's anything else I need to do.
Sir, I have a question.
What's your question?
You typed right now NMCLI connection up ENP03. Is it like, do we have to like enter that in order for it to take place?
Yes,
The effect?
or reboot.
Oh,
So the modify connection basically changes the config file. And the up reads the config file and applies it to the interface.
oh, okay.
Really, what's happening is the config commands are saving to a config file somewhere, just not a public one that we go edit. Excellent question. Oh, we need a new host name. Let's get host that looks like this. And we'll use the .2 version of S01 as the default. And the other one will be yellow. And we should put ourselves into, shouldn't we? I think that's got it. And we will reboot S02 in order for that new host name to be the same everywhere for everybody on the system.
So, sir, my next question is like, for example, if we have to set an IP address and by mistake we have typed something else than what we had to type, how can we edit it?
Oh, that's a great question. While S02 boots, let me just show you on S01. If you recall your command line, right, with the up arrow, then you can use the arrow keys to edit it. Right? And I think you're pretty familiar with that. If you say set minus O for option VI, you can now use VI commands on the command line to edit it. Sounds a little weird, it is, but it's super convenient once you get it. So this is like VI. I can say LS, fine, everything works. But if I hit escape, now things like my arrow keys work. So if I hit the up arrow key, which is K, I start scrolling up. And then I can scroll over, I can do change word. I can hit escape, 0 to jump to the front. Control C to say I don't want to do it. I could also go escape slash and search for something like NMCLI. That's going to search my list of commands until it finds a match. I could then say N for next and keep going up. Lots of interesting tricks to learn to make your life as an admin quicker. And the older and more practiced you get, the more tricks you learn. And I'm sure Windows admins pick up stuff that makes them faster and more efficient. I like the Linux stuff. Okay, so S02 has come back up. Hostname is correct. IP address looks good. Let's see who I can ping. Can I ping S01 on the yellow network? Yes, I can. Can I ping S01 on the blue network? No. Does that make sense? Well, sure. S02 cannot ping. You can get to S01, but he can't ping S01's blue interface. He has no idea how to get things to that 10.1 blue network. Time to investigate the routing. On S02, run the command IP route. S02. And it looks like the lab says it does. We'll talk more about the routing table tomorrow in the lecture. For now, we can look at it and say, the destination, okay, this destination, the packet's going to the 10.2.1 network, which is the yellow network. Send it to this address. This address, well, that's my address. So it basically says if it's on this network, just put the packet on the network, it'll be fine. This is the simplest type of routing. Whenever a system's assigned an IP address, that system also automatically knows how to get packets to that network segment. We never have to set up routing for our local segment, only for remote segments. Oh, let's see, S01 looks like this. Kind of makes sense, because S01 knows about both the blue and the yellow network. W01 has a third entry, which is a little different. Right? We'd expect to see the blue network. We'd expect to see an interface on that NAT gateway. But there's also a default route that looks to go out the NAT gateway. The reason we need this default route is that W01 is connected to the open internet. Whenever W01 wants to send a packet, it has to decide, do I send it on the blue network? Do I send it on the black network directly? Or do I somehow get it out here to the open internet? The way W01 decides is it uses his routing table. And she starts with her locally connected networks. So if she's got a packet for, say, 8.8.8.8, she goes, well, can't put it on the blue. Can't put it on the black, 8 and 10, that's not the same. So I really don't know what to do. I'm going to send it to the router and let the router worry about it. And this default line says just that. The default, if I can't find a better place to send the packet, send it to this IP address, and maybe she'll know how to deal with it. In order to get S02 to talk to W01, we've got to get packets to flow through S01. We need to go from here to here. So we've got to make this guy a packet forwarder or a router. It's really pretty easy. Back in the old days, you didn't even have to do it. You didn't have to do anything because the ability to do IP forwarding was turned on by default. Now, for security reasons, we turn it off by default, but it's pretty simple to just flip it back on. We're going to use a config file. We could call this config file almost anything we wanted. We're going to call it 90-ipforward.conf. In a directory, usr lib syscontrol.d. Remember, when we see a .d, it probably means that it's a config file directory that's going to have little snippets or small pieces of config file that when the application launches will be assembled to make the complete config file. The strategy is implemented to make it so that we don't have to edit the complete config file. Couple reasons for that, right? One is every time we edit a big file, we could corrupt it. Two is we can now separate responsibilities. We can say the basic configuration values are Joe's responsibility and he manages them in these files. These other pieces are Sally's responsibility and she manages them in these files. usr lib syscontrol.d. I think I'll want a reminder. Let's move him up high, him down low, and we'll be able to see where we're going, sort of. Oh, no cut and paste. I'm gonna have to be careful. Oops. I think that looks good. Time to reboot. Oh, but now we need to go over to S02 and tell S02 where to forward packets. We're going to set the default router for S02. So we modify the connection and we're setting a parameter we haven't set before. Gateway. We set the gateway parameter to the IP address of our router, the local one. We're on yellow, so we use the yellow address of the router. Let's go to S0, yeah, S02. We're setting a default route for S02. Gateway, I think. Yes, gateway. Now, when we look at our routing, you'll see we have a default that goes to S01 yellow. Let's see how far we can ping. We're going to start close. We're going to ping S01 yellow, then S01 blue. Then we're going to see if we can get to W01. Ping S01 yellow. That works. Ping S01 blue. This used to fail. I can ping S01 blue. What about W01? Doesn't look like it's working, does it? It's not. But the way in which it isn't working is very important. The way in which ping fails can tell you quite a lot about what's going on under the covers. We tried to send the packet. Heck, we sent the packet. So we've got our routing set up. Whether it's set up correctly, I don't know. We also didn't get an error message back from the router. The router, it looks like the router took our packet and sent it on, happy as a clam. So unless the router's misconfigured, we've probably got our routing set up right. So it looks like we sent the packet to the router sent it on its way, and then we never heard back. I don't know what could happen. Even if we've done everything right, could that still be a problem? Let's follow the bouncing packet. S01 sends an ICMP echo request, specific type of packet. It sends it to S01 yellow, but it's addressed for W01. So S01 goes, no problem, not for me, but I know where to send it. Puts it out on this network. Now the packet has W01's MAC address and W01's IP address. No problem at all. W01 will receive the ping packet. Then W01 is going to say, fine, I'll tell you that I'm alive. Here's an ICMP echo response for S02. Let me see, where do I send it? Well, it's not on the blue. Oh, I must send it out my default. So W01, I think, is sending the response out to the open internet, sending it in the wrong way. In order to get ping to work, we need the routing correct on the host we're going to ping. What this also tells me is if I can ping W01, almost certainly W01 can ping me. But we can't do that now. We've got to tell W01 where to find S02 so W01 can send their response. When a packet arrives with IP, you have no idea the path it took to get to you. None. No history. There's no breadcrumb. You just get a packet. It could have come from any convoluted route. You don't know, you don't care. You've got your own way to get to that address. So packet might come to you this way and the response might go that way. As long as they both meet, everybody's happy-ish. As root on W01, we're going to do connection modify routes. So on the S8, the blue network, when the blue network comes up, we're going to add a route that says, if you're going to yellow, if you're going to the yellow network, send it to S01 blue. I need to be root on W01. And sticking with our theme of not doing any cut and paste today, let's check to make sure W01's up and running. It's gotta be. Yeah, W01's up. But I'm gonna, sure, why not? I'm gonna log on from S01. I know I can get there. You know what? I changed my mind. That's gonna be too confusing. I'm just going to S01 like the lab tells me to. I mean, W01. It'll take a few minutes more, but we'll bask in the luxury of the GUI. Get ourselves a terminal. Become root. Remind myself what we're supposed to be doing from the lab. We're going to add the route. I don't know if I can cut and paste. Let's see if I can. Make my life easier. I don't know what I've got set up on Windows. Hey! And then it's just bring the connection up. I should be able to remember how to do that and type it without making a mistake. Whoa, victory! We have created a working router out of thin air. Okay, out of an operating system that was sort of designed with this in mind. But still, we created a working router. I think we're done. For the graded lab, you're going to do something very similar, just a slightly different arrangement of systems. Any questions?
Yes, sir, I have a question.
Yeah.
So you see in the beginning when you were cloning the S02, like you had to do you had to create S02 by cloning from S01.
Yes.
So I don't understand why you chose link, like the final step before the cloning takes place. There were two options, full clone and link. So why did you choose link one instead of full clone?
I chose link because it would happen more quickly. When you do a full clone, the entire .vdi disk file is copied. So I create a new VM with the same settings, but I copy over byte by byte everything that's in the .vdi file. Takes a little bit. If I use a linked clone, I use the same sort of virtual hard drive linking that we use when we take a snapshot. So S01 S01's.VDI becomes the base. And then the clone happens really quickly because the clone's VDI only has the differences from S01's. And then whenever S02 uses its disk, VirtualBox says, has it changed from the base? If it's changed from the base, then get it from the new little disk. If it hasn't changed from the base, get it from the base. And when S02 does a write, it gets written to its new file. If I'm going to be taking snapshots and stuff, it can get confusing, and I don't have an easy time following the nest of who's in base for who. I've got the disk space and it's fast enough, so I just do a full clone because it's easier for me to manage. Hopefully that wasn't too long an answer.
Yeah, it was kind of long, but then okay. Because last time, whenever we're doing that lab of cloning, I also had to do a clone at that time. I chose the full clone option.
Yeah, I like to do the full clone. It takes longer, but then it's really a lot easier to manage your disks. Because you can get some, it can be possible to like leave VDI files sort of orphaned because you couldn't remove it when you removed this VM because it was a base for this other one, but then you remove this other one and then it's just left. I got burned by that in an old version. So now I just bite the bullet and do the full clone. But if you've got a slow mechanical hard drive or you're running out of disk space, linked clone's probably a good idea.
Oh, okay.
If you come to one lecture this year, come to tomorrow's. I think it's a really useful lecture. I'm going to go quiet now. I won't be far.